Hi students, in this video I'll be going through the 2023 A Math Paper 1 question 9. Right, so this is a question related to the use of differentiation to find the stationary points on the curve. Right, so let's read the question. So a curve has the equation y equals to 1 plus x minus x squared over 2 minus 2x cubed. So find the x coordinates of the stationary points A and B on the curve. So we know very well that at the stationary points, the gradient of the curve will be equals to 0. Okay, so this means that we need to find dy dx for this particular curve, and then we will set dy dx to 0. And then after that, when we solve the equation, we should be able to find the x coordinates, all right? So let's go ahead and do that. So y is equals to 1 plus x minus x squared over 2 minus 2x cubed. Okay, so we are going to differentiate this equation. So dy dx, so differentiate 1 becomes 0. Okay, differentiate x, it becomes 1. Differentiate negative x squared over 2. So you times 2 and then reduce the power by 1. Okay, so that would become negative x only. Okay, then we will differentiate negative 2x cubed now. Okay, you multiply the power in front, so you get negative 6. Then you will reduce the power by 1. Okay, so we end up with dy dx equals to 1 minus x minus 6x squared. Okay, so at the stationary points, at the stationary points, okay, dy dx will be equals to 0. Okay, so we will set this whole thing to be 0. So 1 minus x minus 6x squared will be equals to 0. Okay, so I'll prefer to deal with a positive coefficient for x squared. So what you can do is you can multiply whole equation by negative 1. Okay, so that will make it negative 1 plus x plus 6x squared equals to 0. Okay, I'll just do some rearranging. Okay, so this will be much more familiar to all of us. Okay, so whenever you come across a situation where things are unfamiliar and you are not sure how to go about doing it, so we try to convert it to something that's more familiar to you. Okay, so we can just factorize this quite easily. Okay, so if you do the cross method, you will get this. So there's a plus x, so it should be a plus 1 here and a minus 1 here. So always expand back and check if you have done the factorizing correctly. So 3x squared, 3x times 2x gives you the 6x squared. 3x times 1, positive 3x minus 2x, so you get positive x in the center. Okay, so this is the correct one. Okay, so solving this, so it's either 3x minus 1 is 0. So that will give us x equals to 1/3, or 2x plus 1 equals to 0. So x will be negative half. Okay, since the question only wants the x coordinates of the stationary points, then these two will be the answer already. Okay, so you don't have to go and substitute inside the equation to get the y coordinate. Right? So see, it's not difficult to get these 4 marks over here. Right, let's look at part B of the question. So just keep in mind that the 2x that we got is 1/3 at the half, because we need to use it in part B. Alright, so let's look at part B of the question. Okay, it's given that P is a point on the curve where the gradient is a maximum. So P is another point on the curve. Okay, just now we found A and B, right? Where the gradient is the maximum. So now it's not the y that is the maximum. Now it's the gradient that is the maximum, right? Okay, show that P and the midpoint of AB have the same x coordinate. Okay, so let's do the easy part first, okay? And the midpoint of AB, they have the same x coordinate. Let's find the x coordinate of the midpoint of AB. So we can do that very easily. So remember just now, for A, okay, so they didn't specify which one is A, which one is B, but we know that for A and B, okay, the 2x that we got x equals to 1/3 and x equals to minus half. So we can find the x coordinate of the midpoint of AB quite easily. okay, by just adding up these two x values and then dividing it by 2. Okay, so let's go ahead and do that first. So x coordinate of midpoint of AB will be 1/3 plus negative half divided by 2, right? So that will give you a negative 1/12, right? Okay, so this is not the final answer yet. Okay, so now we need to prove that the x coordinate of show that the x coordinate of P, right, is also equals to negative 1/12. Okay, so that's where we need to think a bit. So you see, when we want to find the maximum, the x coordinates, right, at when y is maximum, okay, what we will do is we will set dy dx equals to 0. Okay, when we want to find the x coordinates, x coordinates, okay, when y is maximum, okay. Also, what we did just now, at the stationary points for y, we will set dy dx to be 0. Okay, so now what we want is maximum, right? The x coordinates when the gradient is maximum, when dy dx is maximum. Okay, so now we will go one step further. When we want to find the x coordinate when y is maximum, we do dy dx equals 0. So now we want to find x coordinates when dy dx is maximum, we will go one step further. We will set d2y dx squared to be 0. Okay, so that's what we are going to do now. We're going to find d2y dx squared, and then we're going to set it to 0. Okay, so just now the dy dx that we got from part 1, okay, if you recall, is this. Okay, so now we can do one more level of differentiation, okay, to find the second derivative. Okay, so differentiate 1, you'll get 0. Differentiate negative x, you will get negative 1. Differentiate negative 6x squared, you will get negative 12x over here. Okay, so now remember, we're going to set the 2y dx squared to be 0. So at P, where the gradient is maximum, okay, d2y over dx squared will be equals to 0. Okay, so in other words, negative 1, negative 12x will be 0. Okay, so negative 12x will be equals to 1. And indeed, x is equals to negative 1/12. Okay, which is the same as the x coordinates of the midpoint of AB. All right. Okay, so from above, we can see that the x coordinates of P, the x coordinate of P and the midpoint of AB, okay, are the same, and the x coordinates are, okay, of the midpoint of AB are the same. All right. Okay, so not a difficult question. Okay, just have to remember about this part lah. Okay, when the gradient is maximum, to find the x coordinates at the point when the gradient is maximum, okay, you will go and find d2y dx squared and then set it to be equals to 0.